The installation position of CTs. In power quality management, the installation position of CT can be divided into two types, open loop and closed loop. These two methods represent different installation positions and algorithms which have different effects on the harmonic compensation performance. We know that the power quality devices are generally installed between the power sources and the load. Its CT is installed close to the power source, which we call the open loop installation. If it is close to the load side, we refer it as load side closed loop installation. In the open loop installation method, CTs are usually installed on the low voltage side of the distribution transformers to compensate for the harmonics detected on the power source side. Generally, this installation method is simple, but it may have lower compensation accuracy and slower dynamic response. It is suitable for harmonic management of power supply systems. In the closed loop installation method, CTs measure the actual load current and the compensation is based on the harmonic current detected at the load. The advantage of this method is higher compensation accuracy and faster dynamic response, but sometimes installation can be more complex. This method is suitable for on-site compensation of harmonics for precision loads. In practical projects, there is also a dual CT combination installation method by installing two current transformers with the same turns ratio at the power source and the output end of the active harmonic filter respectively, and subtracting the measured value of the two CTs. The harmonic current on the load side can be indirectly obtained. This approach simplifies the installation process, especially suitable for retrofitting existing systems. However, it is important to ensure that the accuracy and turns ratio of the two sets of CTs are consistent to avoid affecting the calculation result. Since the cost of CTs is not high, this dual CT combination method is widely used in installations. In HMI of the AHF, you can set the CT turns ratio, installation position and CT direction. This allows for flexible configurations of CT parameters. By choosing the CT installation position appropriately, the compensation effectiveness of the active harmonic filter can be significantly improved, enhancing the power quality and the system stability.